So again, good evening. So yung topic natin ngayon will be development length at saka possibly on reinforced concrete column. Yung development length, I'll just introduce to you yung old na code pa rin na ginagamit. Kasi yung recent, wala pa rin naman gumagamit yan sa board exam. But I'm going to present to you. Okay, ito yung ginagamit ngayon sa recent na NSCP. Sa recent NSCP, kung sakaling yun ang lalabas, malamang ibibigay yung formula. Pag sa mga bagong code kasi, binibigay talaga nila yung formula. So this is the formula for the uh, development length, for deformed wires and tension. So actually, madali kung in the case that this one will be given, ito naman yung mga values dito, ng mga factors. Nakasaad dito yung mga factors. Okay, so wala pang masyadong mga related problems sa board exam na itong ginagamit niya. So we'll just continue with the previous one, just like yung sa load combination na 1.4 dead load, 1.7 live load, yung pa rin ang ginagamit natin because nagtanong-tanong ako sa mga recent na mga nag-take ng board exam at saka yung mga nag-review sa Pinas, ito pa rin ang ginagamit nila sa review center. Okay, yung 1.4 dead load. Not unless during the exam na they are going to specify or be specific with the load combination. Okay, so ito yung sinasabi ko na formula. Okay, this is the formula that now being used in the code. But in the case of sa mga actual na design, ito na yung gagamitin ng mga development length, for sa mga beam, yung mga hook. Okay, so ito yung mga what's this? Factors, na kailangan lang i-check from the table. Okay. Yung dati, ganito, So ito pa rin yung as far as I know, ito pa rin yung pinaka-latest na sa board exam related to hooks, development length. Ito pa rin yung ginagamit niya. Iba yung sa hook at saka iba rin sa development length. Yung mga straight lang, hindi naka-hook. Pagka naka-hook siya or pag naka-L-type, lalo sa mga beam, location ng beam siguro. Habang ganon, if this is the beam, kadalasan naka-hook siya doon, So ito yung gagamitin. 100 dB over square root of Fc prime. That is if Y is equal to 415 megapascal. In other words, if not, and this is the limitation, 8 dB or 8 times bar diameter. Kung yung bar diameter is 20 millimeter times 8 is 160. Okay, but not less than 150. Okay, 150 millimeter. So if other than 415, so magkakaroon lang ng factor. It is just like kung halimbawa, may ka 276, multiply ng 415, or divide ng 415, this will be the factor. Then specific also for concrete cover, for 36 diameter bar and smaller, side cover, normal to plane, not less than 65, or meaning concrete cover could be 65 or greater, and for 90 degrees hook, cover on bar extension beyond hook not less than 50 millimeters. Sa mga 90 degrees na hook, mga ganun. Multiply ng additional na 0.7. So aside from this factor, there will be an additional 4 here. That is for hook. Yung mga hook lang na sinasabi ko. Kasi pagka straight, halimbawa footing, if you have footing, it could just be straight. Okay? Kasi that would depend on the required development length, kung magkaganon siya. Kung available naman is, if the available is greater than the requirement, so hindi na kailangan mag-hook. Okay? So, sa mga straight, mga development length, yung sa footing na nga, itong ginagamit natin. Okay, this one. Okay. 0.02 AB, the area of the bar, times Fy, and then square root of Fc prime. That is for 30 millimeter and smaller in diameter. But for greater than this one, 25 Fy square root of Fc prime. Yan yung mga factors na kailangan. Okay. Let's proceed to this example. Ito lang pinaka-recent, 2008. So, if in case, kasi ito nasa data bank naman, na itong lalabas. So, at least, may chance na alam nyo na, And if there will be related problem to development length, we will be using the new NSCP standard, for sure, they're going to include yung bagong formula. Okay, so let us complete this first problem. So over here, okay, so we have here a reinforced concrete cantilever beam is reinforced with 628 diameter bars. The bars are considered to be top bars. Okay, top bars siya. And then assume side, top, and bottom cover greater than 62.5. So may hit na 62.5. Now, development length if the bars are straight. Okay, so number one, pagka bar yung if the bars is straight, masyado makapal. Okay, so what are we going to use? The formula that we're going to use, yung 0.02. LD is equal to 0.02 AB, area of the bar, Fy all over square root of Fc prime. Okay, so just by substituting it, okay, you have 0.02 AB, area of the bar is just pi over 4. What's the size? It's 28. 28. Hindi mo naman kailangan yung total na reinforcement, yung isang bar lang, kasi you just have to identify the development length of one bar and it's applicable to all. Okay, that's area of the bar, and then Fy is 280 Newton millimeter squared. This one is millimeter squared. This is Newton millimeter squared, megapascal, and then you have Fc prime 28. Now we have LD equivalent to 651.65 millimeter. Now, there is a factor of 1.3 for top bars. Okay, I'll show you kung saan yan. Okay, top reinforcement. Okay, this one. Top reinforcement multiply ng 1.3. Okay, para sa mga top reinforcement. So we are going to multiply this by 1.3. So for top bars, we have to multiply by a factor of 1.3 times 1.3. So LD is equal to 651.65 millimeters times 1.3. So we'll have 847. Number 2, if the development length of the bar is terminated with 180 degrees hook. So, ibig sabihin, let us say this might be the beam. Pero sa actual, hindi naman tayo kadalasan dito 90 degrees. Okay. We're talking about hook. So the formula will be LD is equal to 100 dB all over square root of FC prime. Okay, so we just substitute 100 times 28 square root of 28, which is equal to 529.15. Now let us check with the specification. First, what is the minimum? 8 dB or 150? 8 dB, 8 times bar diameter na 28 is equal to what? 8 times 28.
224 po.
Oh, 224. Okay, 224 or
Sir,
1.
excuse po. So
Yes.
palagay po ng millimeter yung 847.
Oy, nagkulang. Oh, okay. 224 or 150 millimeter. Okay. So, okay lang kasi minimum 224, our computed one is 529. But since our FY is other than 415, okay, since our FY is 280, so we have to multiply with a factor. Multiply with FY over 415. Okay, so we have our LD. LD now is equal to 529.15 multiply by 280 divide 415. Okay, then we have 357. Okay, 357 millimeter. Okay. Number 3, the development length if the bar is terminated with 90 degrees. So, the same pa rin, pero yung if you are going to decide with this 90 degrees, okay, hook. So the same, you have this formula, the same formula, no? LD, actually 100 over times 28 divide the square root of 28 is 529.15. Okay, and then since it is other than 415, so minultiply natin ng 529.15 times 280 over 415 is 357. So anong dagdag lang nito sa kino-compute natin? According to the problem, yung covering niya na not less than 50 millimeter. Ito ang covering niya is 62.5. Cover greater than 62.5. So there will be a factor of 0.7. Okay? So yung 359, okay, therefore, multiply by 0.7 para doon sa concrete cover of not less than 50 millimeter. If it's less than, hindi na kailangan. If not less than 50 millimeter, actually mga 40 millimeter lang naman kadalasan na cover. Minimum concrete cover is 40. Kung ibig sabihin kung 40, di na kailangan ng 0.7. So you just have to multiply LD is equal to, mga case-to-case basis lang to, no? 357 times 0.7. So you will have 3. Medyo may na ang signal. Okay na? Nakita niyo na ba ulit? Nawala.
Wala po eh.
Oh, okay na ulit. Ano? Okay na ulit. Okay, 250.
Wala pa, sir.
Wala pa yung share screen mo, sir.
Okay, I'll check ko. Okay. Ayan. Andiyan na ba?
Okay.
Okay na. Nakita niyo yung screen?
Meron na, sir.
Okay. So this one, you have here a 3-meter wide wall footing. Supports a 300-millimeter wall. It is reinforced with 25-millimeter diameter bars with concrete covering of 75. Of course, the concrete cover for permanently exposed to the ground is 75. Strength of concrete is 21 megapascal and F is 415. Compute the available space for development. So ito parang direct counting lang ito. Okay. So you have here, sorry. So you have here this footing. You have 3 meters. And then you have here a 300-millimeter wall. Okay. This is 300-millimeter. Okay. Now the question is, okay, so this is our bar. The question is to compute what will be the available space. So what is this distance? Huh? We're going to compute this distance. This distance, let's say this one is y. Y is just equal to 3,000 minus 300 divide 7 to 7. So that becomes 1,350. Okay? 1,350. Now, if you're going to deduct this concrete cover, which is equal to 75, what would be this distance? This distance should be the LD, which is available. Okay, the available LD. So the available LD must be equal to 1,350 minus 75. That should be 1,275. Tama? One to 75 millimeter. Now we are going to compute now here which of the or compute the development length required by the code. So ito straight naman ito. This is for number 1. Straight naman ito. Hindi naman siya naka-hook. We'll see. LD is equal to 0.02. We're going to use this one. AB FY all over square root of FC prime. Okay. So this one, this is for 32 millimeter bar or smaller. Kasi mayroon siyang kwan dito pagka Okay. Ito, pagka 36 bar, we use 25 FY. Okay. Pagka 32, smaller is 0.02 AB. So we have 0.02. What's the area of the bar? What's the diameter? 25. Okay. This is 25 millimeters squared. Fy is 415. And then you have square root of C prime na 21. So therefore, calculating it, that is 889 millimeter. So the requirement is only 889, mga less than pa ng 1 meter. The available is 1.2. Pero sa actual, ini-extend na yan na doon. Ano? Pero straight na, walang hook. Okay. So number 3, the question is, when the required development length is smaller, okay, then the space available for development, the practice is to increase the bar diameter. So kasi smaller siya, increase na lang din yung, actually increase yung, you just have to occupy the available length, but when you occupy it, there will be changes in the bar diameter, and then eventually changes of the spacing. Ano? Pagka mag-increase yung diameter ng reinforcing bar, obviously you can also increase the spacing of your the main bar. Ano? Pag tumaas yung diameter, so yung spacing, pwede mo na rin i-increase kasi malaki na yung diameter. Okay, so our available LD is 1 to 75. So the question is, to compute, what would be the diameter to be used? No? If we're going to extend to 1 to 75, just have to use this formula. AB is pi over 4 with the new diameter squared. Fy is 415. And then you have FC prime na 21. Therefore, we can compute here diameter equal to 30 millimeter. Now, if you are going to, it's another problem na, no? Yung S spacing. Pag i-compute nila, they will just go back to AS. Ano? So AS, there might be some changing with the N. Okay, which is just equal to yung dimension, possibly ng kuhan, tsaka yung spacing. Ano? So spacing ng bar. So they will have this relationship. Ano? Okay, so that's it for development length. Let's see. Next one. Okay. Okay, so we'll proceed to another topic. That is if you have